to be talking about water, so be prepared to get wet.
Make sure you have some towels.
All right, first we're going to check in with our science experiment from our first week, growing your own Christmas tree. As you can see, our tree hasn't really grown up anymore, so I might add a little bit more solution, but there is quite a lot of interesting crystal structure, and the color did change. You can see that the yellow and the blue started to separate.
They sure did.
All right, we're gonna put our tree back down. So first up, we're gonna be making some music. So for what you will need for this is glasses of water, and you will need to use glass. So make sure you have a parent there. And you will need a wooden spoon, a pencil, or a paintbrush to make the sound. So we're gonna go ahead and all right, so now that you know we have different sounds, we'll explain how that sound is made. So sound waves travel faster in denser substances because the neighboring particles will bump into one another, kind of like bowling, right?
Yeah, just like bowling.
All right, so I'm going to go ahead and add the
Which is also very
food coloring. All right. I find science more fun with food coloring, especially when you get it all over your hands. Interesting thing about sound in glasses is that the less water there is, the higher the pitch will be. So over here, that'll be a much higher pitch. Over here, much lower. And that is because there's more particles in this glass than there is over here. In an average bottle of water, there's 800 times more particles than an empty bottle of water. All right, so I have prepared a special treat for you. I am going to play you a Christmas song using my water glasses. Now, when you get your kit, you will have some music to play as well. And it will require 5 glasses, but there are plenty of songs that only take 3 notes that you can also play. I just thought this one would be the most fun. All right, let me see. So we're going to use this one as C, and then since this one's a higher pitch, that one is going to be D, E, and then that's F and G. Do I have that correctly? Okay, so I'm going to swap these around because I label them opposite. So when you get them home, make sure you put the fullest glass on your right and the lowest glass on your left. And you can see I actually used a marker and drew where I needed to fill all the glasses to. And to change the sound of the glass, I'm going to go ahead and take a drink out of this one.
It's just water.
Oh yeah,
coloring.
that's right. That is now. Let's try the sound again. I think that one sounds better. Yes. Great. So I'm going to play this song. See if you recognize it.
All right.
Do you guys recognize it?
Is it Jingle Bells?
It is! Thank you everyone. My father will be so proud of me. All right, so next we're gonna move on to some hot chocolate science. So make sure you get your hot chocolate out of your bags.
So we are making hot cocoa, and so get out your packet of cocoa and your marshmallow, and we're going to see how long it takes to dissolve the marshmallow in the hot water. we heated up the water in a tea kettle. You can use a microwave if you want, or do it on the stove.
So what we're gonna do right now is see how hot it is exactly. You can kind of see the water is bubbling.
It is. My thumb out of the way there. Our water is just under boiling at about 180 degrees. Boiling point for water is 212 degrees Fahrenheit. I'm going to stir it a little bit to, if you have not used the Pockies, they are just cookie sticks, and put in our marshmallow. All right, so we've started this at 3:17. And we're gonna go ahead for the other one. I always like to put in the cocoa powder first. That's just a preference.
And then this one we're gonna stir constantly, right?
Yes. All right. Oops. And that one we keep stirring. This one we're just kind of poke at the marshmallow and see what happens. Now the stirring actually helps move the molecules of the water around a little bit more. Water is 1 atom of hydrogen and 2 atoms of oxygen. And when you heat water, it expands a little bit, and those particles, those molecules move faster. And when you're stirring it, you're even making the molecules move faster because you're creating more energy by your movement. So you can see that the other marshmallow is just it's melting, but it's not melting that fast.
And you still have more chocolate on your Pocky. This
I
is
do.
melting chocolate is what it's covered in, so it has a lower point to where it will melt.
Yes, it started to melt as soon as we put it in the water. Just the chocolate. The cookie part is just it's getting a little bit soggy, but it hasn't melted yet.
Yeah. Whereas
It's
mine,
been 3 minutes, and the marshmallow in the J cup is almost gone. This marshmallow is still kind of here. It's very soggy, but it's still there.
so what you're saying is if this is a competition, I've won the race.
Yes, she's won the race. So if you want to make your marshmallow melt faster, keep stirring. And then it dissolves a little bit faster in the water. Or does it? Because this one is almost gone as well.
Ooh. So we started this one almost a full minute after that one.
Yeah.
And they're almost.
Which
at
actually, this is kind of perfect because 3 minutes is about what you want to let boiling water cool down before you try to drink it.
I'm gonna take mine.
And that's how you sweeten up your hot cocoa and do a little bit of experimenting at the same time.
Mm-hmm. At home, you should try out different kinds of chocolate, different kinds of cookies,
Yeah.
and milk. You can also make hot cocoa.
You can also
with
use milk. This will take a little bit longer with milk because milk takes longer to heat up. And milk is thicker, of course.
And you can see it's a little bit different besides the fact that there's cookie on this one.
Yeah.
There's a film of marshmallow on this one.
Still
So if
hasn't
you
dissolved completely.
if you like a little bit of marshmallow just left on the top of your hot cocoa, just do it this way.
Yeah,
Don't
just
keep
throw
stirring.
it in. Don't keep stirring it. So for our next experiment, we have frozen some water balloons, or balloons filled with water. We have some different sizes here. you will be getting some balloons in your bag. These are gonna be latex balloons, so if you have latex allergy, please be aware of that. So we're gonna see what it turns out like. When you freeze water, it expands. Anybody who's ever left a can of pop or a bottle of pop in your car probably knows that the hard way. And supposedly the balloon rubber is going to be a little bit further away from the outside of your new ice orb that you've created with your frozen water inside your balloon. And that makes it a little bit easier to peel away. Because when rubber gets cold, it actually contracts. So let's see what we got going here. Remember
Chop
to
off your fingers.
Yes, remember to have an
Bring
adult
it
around to
here.
help you.
I'm gonna try it over here. And I'm gonna hold the scissors away from my hands.
I'm left-handed.
I just-
I'm awkward.
You can just snip it just.
It moved. And watch out. So you can see we got a nice frozen ice orb here.
This one.
Good
It's got a
color.
lot of blue food coloring in it.
Yeah.
Food coloring in it. So
You can add food coloring if you want to make them look really pretty. These
your
are
hands
great
look really
Christmas
pretty?
decorations. That's why we have towels, guys.
Towels this week.
And they do make pretty Christmas decorations. You can take them outside and line your driveway, set them down in the snow, put them on your porch. Especially pretty if you put them near some lights. So if you got some solar lights or Christmas lights on your porch.
You can actually freeze these with lights in them that
Yes,
are
you can.
waterproof.
If you get
I would suggest getting a smaller baggie and putting them inside
a
it.
waterproof light.
It might take some finagling. You can also use Tupperware to do this activity. Now, some of these, we have items hidden inside. So
Yep.
yours, when you get home with your kit, you might find that. This one is the one that I made most recently.
So it's not completely frozen yet, and neither was that one.
But look at that. You can see that it starts to freeze from the outside. It kind of looks like an egg.
It does. So it does freeze outside inwards. And you can also see, oh gosh, this is so cool, you guys. I'm gonna come around so you can really see it close up. You can see some of the crystal structure of the ice as I drip on the table. So this is really neat. You can actually see those crystal, kind of like stalactites or stalagmites in a cave.
Oh, here's some of mine.
So we froze the tiny ones first, so they were the most solid.
And you can see where we placed them down because you can see the flat side and you can look, and there's a really nice structure of lines through it. So ice is really neat, or water is really neat, because when it freezes, it doesn't freeze and then layer on top of one on the other. It actually makes little hexagon shapes.
Yes. And it's called hexagonal crystalline structures.
Oh, this one's got air in it too. This should be fun.
Woo!
And this one had an alien inside.
So does this one.
Oh man, Jerry Reader, you're
So,
a reader.
so you can really see the crystal structures in here. Let's check this out.
Yeah, I'll show mine too.
Yeah, check it out. It almost looks like a mouth with teeth. Isn't that awesome, you guys?
Here's the back.
So just what the fun you can do with a balloon. And you can add food coloring. If you do have food coloring, be careful as you're opening it and really let it get good and frozen. Freeze it for probably about 12 hours. We froze these for only about 3 hours, which is why they're not all together frozen.
We
Just
thought it'd
tiny
be more
ones.
fun this way if it exploded on us.
Yeah.
You know, since this is exploding science.
Exploding Christmas. Interestingly enough, maybe these are from Mars, because if there was water on Mars, it was frozen water.
Cool. It's one of the only other planets we've been able to find water on.
Yeah.
Alright. So, you wanna build snowman?
Do you want to build a snowman?
Let's go get supplies.
Alright. So, as water freezes, the molecules of water, the particles slow down, which means that it's moving more slowly. And that's why it expands rather than contracts. And that's how it takes the time to actually start to form the crystals. And you can actually disrupt the crystals forming with salt. So the ions, which are the charged particles in salt, and you know there's negative, positive particles, and neutrons, and all those good things, they actually will interrupt the formation of the crystals. And that's why salt will melt ice on a sidewalk.
You can try lots of different ways to melt the ice after you've made your orb. So to get your little critter out, you can do that by using your hands, getting some table salt, some vinegar. You can actually take your cup of cocoa,
What's left of it?
put this big blue orb in it. Oh, yeah.
Yeah.
And try to get out your prize from there.
Hot water will also, of course, melt ice naturally.
Mm-hmm.
Or you can sit it next to something that's warm, like the register of your furnace or radiator.
Mhm.
Let it kind of just slowly melt. Put it in a sunny window if you've got a good sunny day.
Mhm.
Lots of different ways to melt ice, actually.
And there should be 2 different prizes in each one of your orbs. So even if you add food coloring to it, like we did for a few of these, you should make sure to try to melt it down before you put it in a drink or if you decide to toss it into the sink to let it melt.
Yes.
Well, thank you for joining us for Exploding Christmas! We hope you enjoyed it.
Be sure to join us for the next Exploding Christmas next Tuesday on Facebook at 9 a.m. or anytime thereafter. Don't forget to register so that you can pick up your kit. And we'll see you next time.
Happy holidays!